Hi, my name is Fraser and welcome to GPU Solutions. So today we have this Gigabyte RTX 3080 Ti and the user says that there is a short circuit on this card. Now he said that he tried fixing it but he couldn't. So he's also sent me this package with some MOSFETs so we can go ahead and try and replace them with the ones that he sent us. But let's open this card and see what exactly he meant or what exactly he's done. Now, he sent me in this package. This is a box for the RTX 3080 Ti. So I'll just put this aside. Now, I'll go ahead and open this card. Let's see what exactly he meant by he tried fixing it but messed up. That's what he mentioned. So let's go ahead and open the card. Sometimes removing the fans can be a little tricky. So you would need some tweezers to just stick it in so that the locks open up. There you go. Now, Gigabyte has this weird thing where they have this extension connector, and it's not that it's bad, but they twist and break very easily. So you have to be a little careful when removing the backplate because those connectors are stuck or, they are screwed down. But yeah, if you pull them by mistake, it's very weak, especially the connectors which are connected onto the PCB, they break very easily. Not the pins, but the plastic the plastic casing that's around it. Okay. Wow. Look at that. There's solder everywhere. Okay, so this is a shorted MOSFET that he mentioned, and he said he tried removing, but I see the solder blobs everywhere. So we'll have to take care of that. Unfortunately, this is a bad thing. Let's take a look at some resistances. So measuring at the 12 volt, and I can already see that there's a short circuit there. It's reading 0 ohms. Let me take a look here. Yeah, we have a short. Let me take a look on the other side of the fuse, and it's reading in kilo ohms. That means our fuse is blown, but we have a short circuit. And let's take a look at the other one. The second 8 pin looks to be okay. So it's just that one fuse that is blown. So we may have to replace this particular fuse, and we'll do it later during our repair. Now checking the resistance again at this inductor, and we do have a short. So we'll have to get rid of that MOSFET first, but let's take a closer look as to, I see that solder blob that is over there and it's burned. Probably he tried removing it, maybe he couldn't. So let's put in some flux just to make things easier. So I'm going to preheat the board so that the temperature from the bottom rises a bit. Let's try to get rid of this blob of solder. Wow, it doesn't even melt. I wonder what kind of solder he's used. This is a very tough. It's hardly, it's not even sticking to my soldering tip. This is really bad. So I'm struggling to remove this solder blob that's been put on here. I still don't understand why he had to put in some solder, because there's no need for solder. It's not going to come out with by applying any solder to the portion there. Okay, let's try removing it. So I've already turned on my preheater. The preheater is at 120 degrees centigrade. Let's see. And let's try to remove this. So I'll have to remove all the components as well because they are going to get in the way. Maybe it's fused. The MOSFET is fused to the PCB. And by the looks of it, it's the 12 volt side that is fused. So a portion of the MOSFET is still stuck onto the board. I can still see the portion, so I may have to try and remove it. Let's apply some more heat and let's see if we can go ahead and remove that portion from the connector. Sorry, the PCB. So I'm just adding in more flux so that I can go ahead and remove that. I may have to use in some hot air as well just to add to the, you know, add some heat. My only worry is the capacitors. The capacitors are too close, and the position that I'm working in right now. It's a very tight situation here. So the angle that I'm coming in at is from top bottom, making it more difficult, and the space that is there, the hot air is in fact blowing onto my hand, making it more, uncomfortable for me to even work in this area here. So I'm just taking off all the components so that it's easier and the components don't go knocking or flying over. I'm just going to grind it a bit so that makes it easier. Let me just try and be a little gentle here. Let's check if we can save that pad. It doesn't look like it's doing anything. I'm trying to be gentle, but I don't think it's doing anything. I may have to just rip that thing off. Let's see if it comes out. Maybe it is fused to the bottom pad. Maybe part of the pad may rip off. Yeah, there you go. And it's gone. So let me clean this a bit. I think we have lost a bit of copper contact there. We do have a bit on the right side, but on the left, we have lost the entire copper contact. But it is still usable. Let's clean it up. Let's take a closer look. I'll just brush it off with isopropyl alcohol. So the board is still hot, and some more isopropyl alcohol, and that should clean, give us a better view, in fact. There you go. It looks much better. Okay, so we have a bit of copper pad that is still there. Um, I'm just trying to see if there's anything loose. So anything that's loose, we have to remove it because we don't want it to short out the MOSFET when we install it. We'll have to get rid of any components that's there. Okay, looks like we still have a resistor here. So I'll install the resistor there. So you can see that I'm struggling here. The reason being that it's a very tight spot, and it gets really difficult to you know uh, go ahead and move in that direction. So you can see that the angle that I'm holding the soldering tip and the tweezers, it's straight up down because of the spots on the in front of those tweezers. I have the capacitors, and there are inductors this side and capacitors again, so making it a bit difficult to uh, you know hold on to anything that tiny. Okay, my tweezers are a bit bent, so I'll just straighten it out a bit. I think that looks much better. So the board is still hot. I'm trying to rest my hands on the mat, and while it's still hot, because there's no other way. It becomes very difficult to uh, hold something that tiny into place when you're not resting your hands properly. So a bit of solder blob is connecting to the other pad, but that's fine because it's part of the same connection. And even if it makes contact on the other side, it's fine. So I'm just going to blow in a little bit of hot air so that I move the resistor in place. So I have reduced the temperature to from 400. I've reduced the airflow from 60% to 40% because of the capacitors. And what makes this more difficult is the angle where I'm blowing the hot air. It's also blowing on my hand, and it's really making it difficult for me to even hold my tweezers on from the right side. Okay. Let's put in some solder mask because the ground plane is exposed and it's too close. So, and on the left there is kind of a hole in there. So I don't want the solder when I push the MOSFET down. I don't want the solder to spill over onto the ground plane. So that's going to get shorted again. So to avoid that, I'm just going to put solder mask so that it doesn't spill over onto the ground plane. So I'm using UV light. So if you want to know what the paint is, it's UV paint and it dries up with UV light. I think that's good enough. Yeah, okay. So the paint is dried up. I think that's good enough. Let's take this off. Okay, so what we are left with is some components to be reinstalled. So let's go ahead and put in the missing components. So a couple of capacitors, another capacitor here. So what I'm doing is I'm preheating the board a bit before I can move in the capacitor because there's a tendency that the capacitor being so tiny they may fly off, and if it flies off, it's difficult to search for it. So these are 10K resistors. Okay, so the thing here is I'm just going to tag them in place, and when I'm installing the MOSFET, they're all going to be secured. So I won't be focusing now to secure them fully. It's just that I want them to be tagged in place when I'm installing the MOSFET with the kind of heat that's going to go in. That's going to fall in place, and it's going to be secured. No problem. So as you can see, it's very easier for, very easy for the resistors or capacitors. These are 0402s. That's the size of the resistors and capacitors, and they fly off very easily. And the challenge here is the capacitors right in front where I'm blowing the hot air, and it's just the Captain tape that's protecting it. Now I couldn't use the aluminum foils or anything because they take up more space, and it would have made it more difficult. So the only option I was left with are these is the Kapton tape. So this is the MOSFET that I'm going to replace it with. I'm going to display the part number of the MOSFET on the screen. So before we use this MOSFET, I'm going to tin this so that we can, it's easier for it to stick it on the board, or, to solder it on the board, not stick it. I don't want to use the word stick because some have already tried putting glue to fix things up. So yeah, I'm going to avoid using the word stick. So these are the only pads that are left with. Now, the ones on the left are all 12 volt, so it doesn't matter if it, touches. So 12 volt is fine. The next ones are what I don't want them to touch the ground. So yeah, let's prepare this. So these are wires that go onto the back of the board and they connect to the 12 volt directly to the 8 pin. And let's prep the rest of it. So I'm going to tin the MOSFET before I can install it. So tinning is nothing but just applying a little bit of solder so that it wets the entire pads at the bottom of the MOSFET so that it's easier to make contact and fuse to the board, the PCB when I install it. So it's a good practice to tin the pads. You can use it without tinning as well, but when you tin it, it makes your work a little bit more easier. So there you go. Now the power plane and the ground plane. Let's start off with the ground plane. That looks good to me. Let's try the ground plane on the other side. I think that's too much solder, but it's fine. It's workable. Okay, let's take this and prepare it. So I'm going to preheat the board first. So the board is up to temperature. I'm just going to position it and check. Yeah, this looks good to me. I think I can install it here. Let's turn on the preheater. Just move the board in focus. Okay. So I'm going to hit the pad first. So when I place the MOSFET on the PCB, it sticks to the pad, and it's going to make it easier for it to fall in place. Okay, there are some pads which don't have solder, so I'm just going to tin it. Not necessary to have solder, but I'm just going to tin it because the solder is on the MOSFET, so which is going to stick to the pads. Let's place the MOSFET now. There you go, it's stuck. Now let's apply some more heat. So I'm going to continue applying some heat till the solder underneath melts. There you go, it's melted. And now I'm going to just push it down. Okay, let's push it down. Okay, so if you're wondering where's the 12 volt coming from, it's the pads that were, underneath the MOSFET. What is left of it? That's where you get the 12 volts from. Now, there was a capacitor on the right and the left, which we will not be installing because those are just filter caps and we don't require that. It's fine if you're not using it. So I'm just going to uh, run the hot soldering iron over it. So if you see that at the bottom right of that MOSFET, the pads may be making contact, but it's fine because it's all three at the bottom are all ground. So it's not required. It's okay. We can still work with it. So let's take a look if we still have a short. Okay, I'm not getting a good contact here. Let's try here. And you can see that the short is gone. So we no longer have a short. So we may have to replace this fuse as well because the fuse is blown. Let's get rid of the fuse. So this fuse is 20 amps. So I'm going to replace it. So what I'm doing here is first I'm applying leaded solder so it's easier to remove the fuse, or basically any component. So it's easier to add in some leaded solder and then take it off because then you can remove it with less heat. Because with leaded solder, unleaded solder, the heat required is more, much more compared to unleaded solder, compared to leaded solder. So I'll just use my soldering iron as well, just to give it some added heat. And there you go, the fuse is off. Let's replace it with another 20 amp. So I have a 20 amp fuse here. So I'm just going to add in some more flux. Let's position it first. I think that's okay. I think that's good enough. Let's put in some flux and then we'll get the rest of the things in place later. So I'm going to tag one side of the fuse with the soldering iron first and then come in with the hot air station. Let's hold this down. So I'm just going to tag on one side. I think that's good enough. Let's add in some on the other side. Now this is not going to go down. It's just that I will have to use hot air. Now to do something like this, you either need tweezers, hot tweezers, or you can do it with two soldering iron handles, or you can do it with hot air. And just wait for the thing to melt, the solder to melt, and once it's melted, I'll push the fuse down onto the pad. Okay, looks like it's melted. Now I'll push it down. Looks like on the bottom it needs some more solder, so I'm going to apply some more solder there. Okay, let's add in some flux and make it look better. I think that's good enough. Yeah, that's done. So the fuse is secured. It's in place, and it's good to go. Okay, now let's check some resistance, and we'll take a look after the fuse. I think let's do it at the inductor, and our capacitors are charging as normal. That looks good to me. So our short is gone. I'll wait for the board to cool down and put it on the bench later. Okay, so the board is on the bench, so I'm not going to put the card into Windows. I'm just going to check if our card is getting detected and if we get an image. So it's the good practice before you assemble the entire board. Just waiting for the image now. And there you go. So I'll turn this thing off and I'll assemble the card now. Okay, it's off. Let's take it to our workbench. So this card is going to require some new pads on the memory. But before that, let's go ahead and clean it with flux. With isopropyl alcohol. There's a lot of flux that it looks a little bit untidy if you leave all the flux on the board. So it's a good practice to clean off the flux that's left, because it's more presentable, should I say. It looks much better. Now let's replace the pads as well on the memory. So the liquid that I'm pouring on the pad, that's the cotton pad, is isopropyl alcohol. Okay, this looks better. Let's replace the pads. That looks much better. Add in some paste. And time for the assembly. Okay, so we are booted in Windows. The drivers have been installed. So I'm going to run some tests just to make sure that our power draw and everything is functioning normal. Now I'm just going to run FurMark and a couple of other tests, just to make sure that our stability is achieved. Now, as I can see that our power draw is normal. It's drawing about 98, 99% of power, which is absolutely fine. The temperatures are good. Um, the clocks are good. You'll always notice in FurMark that the GPU doesn't boost to its highest, but in other tests you will find that it will boost. But yeah, in FurMark it doesn't. So many of them commented that the when I run the FurMark, it doesn't. It's the GPU is not boosting because in FurMark it doesn't. Okay, so I'm going to run a couple of other tests, and once if everything is good, it's a fix, and I'm going to send it back to the owner. So this repair is complete. So I hope you like this video. I hope you learned something from it, and yeah, when it comes to DIY, make sure that if you're not comfortable, you don't have the right tools, you send it to the person who does it, rather than you trying it and messing it more. I do have a website, gpusolutions.net, where I do accept orders from all over the world. If you're sending your GPU for repairs from outside the UAE, just make sure that the shipping doesn't exceed the value of your GPU. The link to book your repair is in the description of this video. Just click in the link and you can fill in the form. So there's a ticket that gets raised after you fill in the form. And you can send in your GPU for repairs or upgrades. So currently I only offer upgrades on the RTX 3070 and the 2080 Ti. There are other cards that are work in progress and are not complete. I am working on other cards for upgrades, but that's for another topic. Okay, so I hope you like this video. If you did, please hit the like button and subscribe for more content like this. Don't forget to hit the bell icon so that you get notified when I release a new video. You can also join in as a member, and your contribution makes a big difference to me. So thank you for watching, and you have a good day. Bye for now. Cheers.